All right, so this is the next slide. Okay, right here. All right, you're gonna draw some boxes. Now, if I were to ask you, how many particles do you think everything in the universe is made of? You might say, proton, neutron, and electron, right, Mr. Laracamasi? Well, yes, but did you know protons and neutrons are made of smaller things called quarks, and that there are 6 kind of quarks? Well, we're going to draw the particle zoo, also called the fermions. So, on your paper, draw this. So, these at the top, okay, are called quarks. I'm going to call Q-U-A-R-K-S. And these are called leptons. Go ahead and write this down. We have the quarks and the leptons. Okay. There are actually 12 fundamental particles, just like the 12 disciples and the 12 tribes of Israel, that everything is made out of. It seems that God really likes the number 12. So, let's start like this. First we have U, C, T, D, S, and B. These stand for up, down, sorry for jumping around, charmed, strange, top, and bottom. Okay, so you have these different columns, right? These different columns are called generations. So this is generation 1, this is called generation 2, and this is called generation 3. All right, got it? These are our generations. Okay. These are the leptons now. So first we have the electron. And then we have the mu. Then we have the tau. And then we have the neutrinos. So first we have the first neutrino, which called the neutrino of the electron neutrino. I'll draw the second neutrino, which is the mu, and then lastly the third neutrino, which is called the tau. Okay, so what do we got here? We got the electron. Maybe you heard of that before, yes. And then you have this one's the muon, that's what it's called, or the mu particle. And then we have the tau particle, which is called the tau particle. All right, and then finally, lastly, we have the electron neutrino. Okay, then we have the mu neutrino and the tau neutrino. And thus you have the particles that everything is made of. Now, I want to tell you something. So what are atoms made of, right? Well, if I think of an atom, it kind of looks like this, right? So this is the nucleus, and then it has these electrons that go around it. Okay, so there's the electrons and the protons and neutrons. The protons and neutrons are made of up and down quarks, and then we have the electrons which go around it. So pretty much everything in the universe is made of generation 1. Up, down, electrons, and not neutrinos. Where are neutrinos? Well, neutrinos can actually pass through anything. So at any given time, perhaps now, right where you're sitting, there are millions of neutrinos passing through the Earth. Some coming down from the floor, others coming through the ceiling and the walls. They're going, going through everywhere, maybe even through our brains. We can't detect them or see them though. And how do you detect something that goes through everything? Okay, so next we have our force carriers, also called our vectors. There are 4 vectors, or 4 forces. There are 4 fundamental forces which make up the whole universe. Everything is made of these forces, sort of. Well, I mean, it's made of the stuff that it's made of, but like the forces affect them, right? So the first force is called light, or electromagnetism, and it's represented by a gamma, which is the 3rd letter of the Greek alphabet, but this is the lowercase. It looks like a little fish thing, okay? And this is called the photon, the particle of light. And the force is called electromagnetism, also called EM, or electromagnetism, okay? What's that? The next one is going to be the graviton. The graviton is represented by the capital G. Okay, right. And it's the force of gravity. Gravity is a very important force which helps bind matter together, matter which has mass. Especially, you can see gravity's effects on the large scale. On the small scale, gravity is a very weak force. But on the large scale, you can see its great impact. The graviton is a theoretical particle. There's no evidence of it existing. It's only theoretical. However, perhaps one day they will find evidence of it if the theory holds true. Perhaps you can be the one who finds evidence of the graviton. Next is going to be a particle which glues everything together. It's called the gluon. Okay? The gluon is a particle called the strong force. Called the strong force. The strong force holds the atomic nucleus together and keeps all of the protons and neutrons bound up together inside of the nucleus. The next after the strong force is called the weak force, which is represented by a W, and the particle is called the W boson. And the force is called the weak force. Cool. The weak force holds protons and neutrons together. Otherwise, the protons and neutrons would fly apart. Now, there's one more particle that I'm going to put over here. This is the particle of mass, and it's called the Higgs boson. Higgs boson. Okay? For a long time, there was no evidence of the Higgs boson, the particle of mass, which is called a scale, a scalar. One sec. And the particle of mass was not discovered for a long time until they discovered it, and then they knew it was existing, and they had direct evidence of it. And it's a particle that's associated with mass. You might wonder, why does everything have mass? Well, it just does. It's the way God made it. But there's also a particle that's associated with it.